welcome to Best Academy. Now, in this video, I'll be taking you guys on derivative of a function as plus b all raised of n. So, how to differentiate a function that looks like this statement. Now, first of all, we have actually known more about the method of derivative or differentiation. We say the first method is on general method. The second method is chain rule or composite method. Either I call it chain rule or composite method. And what are the methods that fall under chain rule here? Now they are said to me, the first one is as plus b or raised of n. Once again, we have exponential function fall under chain rule. Please take note. Once again, we have logarithmic function fall under chain rule. Once again, all trigonometry fall under chain rule. Please take note of this. So we are going to consider this one after the other here. We are going to consider this guy. We are going to consider this guy. We are going to consider this guy and also this guy here. Please take note. So what you just have to do here is to subscribe to the channel and get all the package on derivative and also other courses like physics and other complex topics too. Okay, now let's try to deal on this guy here, that is as plus b or for n. Now, what you should understand here is that whenever an expression is in captive with a higher power or with a lower power, at that point we can use chain rule to differentiate that. But this is the shortcut here. I'm going to show you guys the shortcut. Whenever we have inside and outside, this thing, whenever we have inside and outside, to differentiate that function there, we always use the derivative as inner derivative times what? Outer derivative. So let's try to consider this one here, please. Okay, let's try to consider this function here. If I have as plus b always for y, if I have a function like this, y is equal to ax plus b always of n. If you look over here, we have inside. The inside here is ax plus b. We have outside. The outside here is what? Bracket open, bracket close of n. Please take it. So how do we solve anything that looks like this? Our dy over dx will be equal to inner derivative times what? Outer derivative. So we have to know the inside. You differentiate the inside to get the inner derivative. You differentiate the outside to get the what? Outer derivative. Please take it. So let's try to solve some examples here so that we can be used to this and play along with this particular function. Alright, let's solve a question here. Let's solve some examples here. The first example is if n is equal to 5t plus 3, open and close bracket always for determine the n over the t. It is said to be the n over the t because the dependent is n. Independent data is what? T. So it's going to be the n with t. So it looks like this. So whenever an expression or a function looks like this, that means to differentiate this will be the inner derivative times what? The outer derivative. So it means that our dn over dt will be equal to inner derivative times what? Outer derivative. So the next thing I'm going to do here is to identify or to know the one that is the inner. When you differentiate that guy, you are going to get inner derivative. Know the one that is the outer, differentiate the guy, you know what? Outer derivative. So the inner here is one inside. So inner is said to be 5t plus what? 3. So differentiate this guy here to get inner derivative. What is the answer? Inner derivative will be differentiate this guy. There's an invisible one here. So take the power here down to the base, subtract 1 from it, it's going to be what? 5. Please take it. So whenever you take 5t plus 3 out, what are you going to see? You are going to see bracket open, bracket closed, raised of what? 4. So that will be our outer here. That is outer is said to be bracket open, bracket closed, raised of 4. So this guy is just like what we know before. It's just like if I have this to be x raised of 4. If I have x raised of 4, what does it mean? It means that I'm going to differentiate this by taking the power down to the base and subtract 1 from it. So let's get the outer derivative here. The outer here is going to be 4 bracket open bracket raised of 3. Sorry, raised of 3. What I did here was to take the power here down to the base and subtract 1 from it, just like something like this. Please take note. So let's replace this. We have gotten the inner, please take note. We have gotten the outer. So replacing them here, the inner is said to be 5 times, the outer is what? 4. Please take note. What it is? Bracket open, bracket close, raised of 3. Now, to simplify this, I'm going to have 20 open and closed bracket raised of 3. I'll ask myself this question. What am I going to place inside this empty bracket? Because in mathematics, we don't have anything like empty bracket except in set. And this is not set, please take note. So what am I going to place inside this bracket is what is in the bracket from the equation. So what is in the bracket from this equation here is what? 5t plus what? 3. So this is going to be 5t plus what? 3. This is my answer here. So we can't open this bracket here. This remains the same except the power is said to be 1. If the power is said to be 1, we can easily expand this. Okay, thank you so much. Alright, let's take an extra question here, question 2. Find the value of dy dx at the point s equal to 5, given the function y equal to 2s squared minus 5 or equal to 2. Now, of course, we are given options here. Let's see if there's any option that is valid to what we are going to solve. Now, first of all, if you look at where this function here, I told you guys in differentiation, you identify the function, you know the method to differentiate that. This is y equal to 2s squared minus 5 or equal to 2. It's looking like this function here. And if it's looking like this function here, can be solved using inner derivative plus the outer derivative. So now let's try to apply this here. Let's try to apply inner and outer derivative here. So solving this, our dy over dx will be equal to the inner derivative times the outer derivative. So now let's try to know our inner. The inner is the one inside. So our inner here is said to be 2s squared minus what? 5. So our inner derivative is differentiate this and what is the answer? 4s. So let's pick up our outer here. Whenever you take this 2s squared minus 5 out, what is going to left here is open and close bracket raised for 2. Please take it. So our outer here is said to be open and close raised for 2 here. So our outer derivative here we equal to differentiate this line. If I have something like this s squared, differentiate this will be 2s. Please take it. So differentiate this line here. I will take this one here down to be what is the answer? 2 open and closed brackets. Please take it. So I have known my inner, I have known my outer. So to find dy dx of this guy here is going to be very simple here. I have to replace it here. So replacing our inner derivative, the inner is 4x times the outer is what? 2 open and closed brackets. Now ask ourselves here, what am I going to place as my, what am I going to place inside here? Since there's something like empty bracket in mathematics, is what is in the bracket from equation. So what is in the bracket here is what? 2s squared minus what? 5. Let's take raised of 1. And anything raised of 1 is this here. So this will be equal to, let's simplify this. 4 times, what is the answer? 8s into 2s squared minus 5. Please think of this. If the power is set to be 1 here, you can open the bracket. But if the power is more than 1, at that point you can just keep the answer like this. So the power is here is 1 here, we can expand this here. So expanding this, our dy over dx will be equal to plus 8 times because of 16x raised to 3 minus this give us what? 40x. This is my answer. Now we have gotten this, but this is not the last. Alright, let's try to evaluate this here. Now, of course, we have solved this guy here, and this is going to be 16 or 5 raised to 3 minus 40 times 5. So now let's try to evaluate totally. This will be equal to, remember, 5 raised to 3 is 125, right? This will be 16 into 125 minus 40 times 5 is going to give us 200, right? We are going to have 200. Please take note. So now let's evaluate totally. 16 times, let's get this one here. 16 times 125. What is the answer there, please? 16 times 125. What is the answer? 2000. That is 2000 minus 200. So that means our dy over dx will be equal to 1800. Am I correct? Okay. So this is our answer here, and the option is said to be B. Okay. Now subscribe to the channel to get much of the advanced question on chain rule, that is mostly on exponential, logarithmic, and again trigonometry. Thanks so much.